So we're doing the chemistry behind toys.
There are thousands of toys that exist today, and although we may not put much thought into it, many of the toys we played with as kids, as well as the newer toys that are coming out in recent years, use some sort of science. So today we will be covering 3 different toys that have a different type of relationship with chemistry.
So the bath bomb equation is, it's neutralized, and then it's basically just an acid plus a base produces a gas, a salt, and a water.
The magic sand equation essentially is silicon dioxide plus trimethylsilanol, which yields magic sand, which has no known chemical formula.
The chemical equation for slime is basically a boric acid and water, which creates a borate ion and a polyvinyl alcohol.
So item bath bombs. The making of a bath bomb is basically just like what you go through to like get everything, but the ingredients are citric acid, baking soda, cornstarch, Epsom salt, food coloring, essential oil, and then you can also add almond oil, rubbing alcohol, and witch hazel. You can put it in any kind of mold. You just have to be able to like, get it so it can be any shape you want, and then you can like infuse them with flowers or glitter or sprinkles or basically anything else. The purpose of a bath bomb is basically just to make your bath pretty, but you can also use it as like a hobby, or you can make money from it because a lot of people like them and don't want to spend the time to make them. So the uses are, it's a great stress reliever because like if you put certain essential oils in it, it like has benefits for your body, and then you can use it as like a craft with your friends or your family. And then, like I said, the benefits, it just depends on which essential oil you use. The chemical properties is the main components are baking soda plus citric acid. Baking soda is like a passing carbon dioxide and ammonia through table salt. And then citric acid is plant-fed glucose, which is then treated with sulfuric acid. So the first picture right there is the dry ingredients of a bath bomb and the food coloring being mixed to create the color. And then the one right below it is after it's been mixed and they're putting it into a circular mold. And then up here on the top right corner, they are putting the mixture into heart molds. And then this is just all of the ingredients you would need for like a bath bomb party. These are all 3 just different bath bombs dissolving in water. And then in this picture, they have bath bombs with flowers and glitter and sprinkles and seeds and stuff. And then these are just different like molds.
So the toy I will be presenting is magic sand. Magic sand can be bought or sold. It can be bought or made. It was originally thought to It was originally made to clean oil spills with the motto, repel water, attract and trap oil, but then it became famously known as a toy, and the rest is history. So the characteristics of magic sand, it can be molded underwater, and so when you take it out, the structure collapses and it is completely dry. In this gift that it can be seen how after magic sand is taken out of water, it just turns into its dry state. For the chemical composition of magic sand, you can use ordinary standard sand, which is mostly known as silicon dioxide, and trimethylsilanol, which is what makes sand hydrophobic or water-fearing. And over here, hydrophobic, water-fearing. One common example is oil, which can be seen in the picture over here. When oil is poured into water, it repels and it doesn't mix well. For chemistry's role in magic sand, when the ingredients mix, trimethylsilanol forms covalent bonds with hydroxyl or OH groups on sand molecule surface, and this is what replaces the hydrophilic, which is water-loving, the hydrophilic properties with hydrophobic properties, and that is why it stays dry even after it's submerged in water. In this picture, we have a regular sand particle. It has a lot of bonds with regular H2O, and that is why it's hydrophilic. over here is the magic sand particle. If you see the trimethysol, like it is around the sand particle with the hydrophobic parts over on the outside, and so that's why water will not actually bond with the sand particle.
My toy that I covered is slime. Everybody under the age of, well, there is no age limit. Everybody under that criteria of having access to the internet is involved with slime. Either you've seen videos made by slime, or you've even made slime in school or anything like that. Slime properties. Slime doesn't have an ionic or covalent bond. In this reaction, it's actually a hydrogen bond. Glue has a pH of 5, and it is made of hydrogen, oxygen, carbon, and boron, sodium, and borax. Other elements can be added to the change to texture of the slime, like styrofoam balls, little glass pebbles, Orbeez, or glitter. Anything you want can be added to slime. It flows like a liquid. Its ability to flow or viscosity is not constant. So it's a fluid, but not like a regular liquid. It's called a non-Newtonian fluid. It's originally used for, well, its discovery was an accident. It was supposed to be making synthetic rubber for tires and other things like that. But they figured out that no matter what you do with slime, stuff always sticks to it. So they started using it for cleaning. It's now used for toys, entertainment for all ages, and a learning tool. A lot of autistic kids, they need a sensory activity. And so it's been used in classrooms and in special ed classrooms just to give them something to do while they're trying to learn. There's different types of slime, and I have a list of all of them. Fluffy slime, clicky slime, unicorn, glitter, magnetic, and edible slime. Edible slime is my favorite because it's made of water, Starburst candies, and cornstarch. So you can just eat it after you're done making it. Magnetic slime is glue, water, borax, and iron shavings. You can take a magnet over it, and you can wave it over top, and it moves to follow the magnet. Glitter slime, basically that's explainable. Just put glitter in it. Unicorn slime is shaving cream and glitter. Anything you want, basically. Clicky slime is just your basic slime, which is borax, water, and glue. And fluffy slime is glue, water, borax, and shaving cream. This is an example of all the slimes. This is the fluffy slime with the shaving cream. This is the foam, which has the styrofoam balls. This is glowing, which they use glow-in-the-dark glue. This is butter slime, which is a shaving cream based and clay based slime. This is a face mask based slime, so it's clear and it's very clicky and peelable. This is fishbowl. It is used to have like little glass beads inside of it, and then your clear slime up top, which is your basic slime. And this, they have the DIY version. I have no idea what happened to the artwork here. You add water and borax, the glue, and then you add your food coloring, mix it together, and it starts sticking immediately. And you make it to the texture that you want it to be, so it's not too sticky. And then this is your final product. See over here, people have added different types of things to it. This is the clear glue slime, and you put blue food coloring along with purple to make the color. And then you can add just any type of little things that you want. Oh, there he is. For our conclusion, as you can see throughout our presentation, chemistry exists in the simplest of things that can be used for many different purposes. Toys, whether old or new, can be complex in scientific terms and can properly utilize the aspect of science for fun. These are our references.